Now in this question we have to find the value of the admittance at a resonant frequency. So first we will have to calculate the resonant frequency of the circuit. Now we know that resonant frequency is that frequency at which the source voltage and the source current are in phase. Now the source voltage and source current are in phase, it means the net reactive component in the circuit is 0. Therefore for the net reactive component in the 0, the admittance should be consisting of purely the conductive part, that is the conductance. There should be no part of the BC or BL. So first let us find the total admittance and then make the imaginary part equal to 0. Therefore in the circuit, if you see, let us say the admittance of this branch is Y1, of this branch is Y2 and of this branch is Y3. So let us calculate first Z3. So you can see Z3 will be equal to RL plus JXL. Therefore Y3 will be inverse of this. So Y3 will be equal to 1 upon RL plus JXL. Let us rationalize this one. It will be RL minus JXL upon RL minus JXL. Therefore you can see Y3, it is coming as RL A plus B into A minus B, that will be A square minus B square, and J square minus will be plus. So it is coming as RL upon RL square plus XL square minus J XL upon RL square plus XL square. Therefore the net admittance Y, this will be Y1 plus Y2 plus Y3. Let us substitute the values. Y will be equal to Y1, Y1 will be 1 by R, that is 1 by 1, plus Y2 will be equal to J BC, BC will be omega into C. Omega we have to calculate, C is given as 0.5. Now let us keep it in terms of the C only so that we can get the formula and then we will solve it. Let us say this is R, let us take this one as R and this one as C. So this one 1 by R, this is JBC, that is J omega C, plus Y3 will be RL upon RL square, plus let us put the value of XL, that is omega L square, minus J omega L upon RL square plus omega L square. This can be further written as Y is equal to 1 by R, I am separating the real and imaginary terms. So real term will be 1 by R, RL upon RL square plus omega L plus whole square plus J omega C minus omega L upon RL square plus omega L whole square. Now we know that at the resonant frequency this imaginary term will be equal to 0, therefore equating it to 0, so making the imaginary term equal to 0, you can see omega C, this will be equal to omega L upon RL square plus omega L whole square. Omega and omega will get cancelled, so you can see RL square plus omega L whole square is equal to L by C, or omega square L square is equal to L by C minus RL square. Therefore from here you can see omega square, this will be equal to 1 by LC minus R square by L square. Therefore omega is coming as under root of 1 by LC minus R square by L square. Now if you substitute the values of L, C, R and L, you will see omega, the resonant frequency, it is coming as 1 radian per second. So this is the value of the resonant frequency that we have got. Now we want to calculate the net admittance of the circuit at this frequency. So now you see we will substitute the value of omega in this equation. When we will substitute the value of omega in this equation, this whole term will be equal to 0, because we have calculated by using the condition that this is equal to 0, because this is the resonant frequency. So, this will be equal to 0. So, this is the value that we have to substitute. Substituting the value of R, RL and omega over here. So, we can see Y is coming as 1.5 moho. So, this will be the answer. So, when the resonant frequency, the admittance of the circuit, it is coming as 1.5 moho.